Okay, this is going to be Chapter 3, Section 5. We're starting a new unit. Okay, this is Unit 7, and Unit 7 is about properties of two-dimensional objects. Now, we've been talking about two-dimensional objects for a while. We've learned how to prove triangles. We know lots of stuff about triangles. We just learned all about quadrilaterals. So this unit is basically just kind of wrapping up two-dimensional objects. It's basically all the other two-dimensional objects that we haven't talked about. So other than triangles and quadrilaterals, all the other two-dimensional objects are kind of grouped together. So this unit might feel a little bit disorganized, but if you think about it just being everything else besides triangles and quadrilaterals. So we're going to be doing polygons. Now, first of all, you need to know what a polygon is. Polygon is a closed figure with at least 3 sides that are segments. Okay? This word is important. That means none of the edges can be curved. Okay? So an example of a polygon would be that. This is not a polygon. This one is. Okay? So it cannot have curved edges. Straight edges only. Okay? We have 2 types of polygons. So we have convex and concave. Okay. A definition I saw one time for convex said no exterior diagonals. I'll show you what that means, but then I'm also going to tell you a different way you can think about it. Alright, so if I have that shape right there, and I draw all the diagonals that I can possibly draw in that shape. Remember, a diagonal goes from one corner to another. So that's a diagonal, that's a diagonal. From this point, I could draw a diagonal there, or I could draw a diagonal there. From this point, I could draw a diagonal there. And so that's all the diagonals in the picture. Notice none of them went outside the picture. Okay. Concave if I have that shape right there, that is technically a polygon. It has straight edges, it's a closed figure, and it has at least 3 sides. Okay? Now, let's draw some diagonals. That's a diagonal. That's a diagonal. What about this diagonal right here, though? From one corner to another. That one went outside the figure, didn't it? So that makes it concave. Alright, that's the technical definition. The way I always think about it is concave means it caves in to the figure. Okay, convex means none of the angles are caving into the interior. Okay, if any of the angles cave into the interior of the shape, then it's concave. Another vocab word, another types of polygons is you will see a regular polygon. Regular means all sides and angles congruent. So if they say a regular pentagon or a regular septagon or whatever, it means all of the sides are equal. Okay? We have 2 formulas that you need to know for polygons. Okay? Interior angle. Okay? The interior sum of the angles is equal to n minus 2 times 180. Okay. The exterior sum is always equal to 360. Now, I'm going to demonstrate in class this formula, but I'm going to go ahead and tell you right now, it's actually really interesting. No matter what kind of shape, no matter how many sides it has, if you take all of the exterior angles and you add them up, then it will always equal 360. Whether it's a triangle, a quadrilateral, whether it's a dodecahedron, it doesn't matter how many sides it has, it will always add up to 360. I'm not going to do an example in this space, but I'm going to review your information on what is an interior angle and what is an exterior angle. So, let's say I have that polygon. Okay? If I take one of the lines and extend them out in one direction, this angle is an exterior angle. Obviously, you know what the interior angles are. Okay? It's the exterior ones that people get mixed up. Okay? So that is an exterior angle. Remember, if I extend both lines, that's an exterior and that's an exterior. This one is not. Okay? That is a vertical angle. It's vertical from the interior. Remember, an exterior angle must touch the sides. It must be next to the sides. It has to be adjacent to an interior. Okay? So, some examples of this. Okay. This is 117, 100, x, 115, and 105, and obviously this is not drawn to scale. But if I give you that picture and I ask you to solve for x, okay, we have to set up some sort of an equation. The first thing you have to do is figure out what they're supposed to add to. So think about it. When we were doing triangles and you had pictures like this, you knew that they added up to 180, so you would add them all up and set them equal to 180. But in this case, it's not a triangle. So what does it all add up to? Okay, that's when we use our formula. There are 5 sides. So, if we use our formula, the sum of the interior angles should equal n minus 2 times 180. This is the formula from the previous page. N is the number of sides. So that's 5 minus 2 times 180, which gives us 3 times 180, which is equal to 540. So that means all of these should add up to 540. So now we can write our equation. 105 plus 117 plus 100 plus 115 plus x should equal 540. If I add all of those up, that gives me 437 plus x equals 540. And if I subtract it over, we get 103. Next example. Yes, it's in the top right-hand drawer. Okay, so in this example, we have a triangle, but notice the interior angles are not labeled. The only thing that's labeled is the exterior angles. We have a good idea that we're probably going to be adding these things together, kind of like we did here, except what are we going to set it equal to? So we know we're probably going to be adding them together, because that's what we've done in our other problems. But what should they equal to? If I add the exterior angles, what are they equal to? Well, if you flip back to the last page, it says that all exterior angles, no matter what kind of shape it is, will always equal 360, no matter what. This number, if you're dealing with exterior angles, will always be 360. So we get 3x minus 2 equals 360 when we simplify. Add the 2. And divide by 3. And so x equals 120.67. Okay. Another thing to point out, just in case you have any problems in the book, an exterior angle and an interior angle are always linear pairs. Okay? Actually, let's go back and write that right here. Another thing to know about interior and exterior angles is an interior plus an exterior will always equal 180 because they are linear pair. Okay. Last example. The sum of the measures of the angles of a polygon within sides is 2,880. So let's just review what we've learned in this section. Other than some definitions, we've also learned how to plug into the interior formula and how to set equals for the exteriors. But in both of these cases, both of these previous cases, we knew what the shape was and we knew how many sides there were. All we had to do was use the formula. Okay? In this case, we don't know how many sides there are. So we're actually doing this backwards. Because they are talking about interior angles, if they don't say exterior, then you can assume that they mean interior. Because we know that they're doing interior angles, then our formula is the sum of the interior angles equals n minus 2 times 180. Now, where do I put this number? This number represents the sum. So in this case, they are giving us that number. So when we plug it in, we have an equation that we can solve. Okay. Divide by 180. That gives me 16 equals n minus 2. Add 2. So in this case, there were 18 sides. So be prepared on the homework that not only to be able to use these formulas directly, but also indirectly plugging in for the answer and then doing the problem backwards and solving for the n. Okay, that's it.